So this is an IB question from 2009, and it involves volumes of revolutions. So I want to show you a little bit about how it works. I have drawn out some of the information that's given in the question. Specifically, that we have the graph of y equals the square root of x. This is occurring between x equals 0, which is right down here, and x equals a, which is a vertical line that I have drawn here. And it's rotated 360 degrees about the x-axis. So the first thing that we might consider doing is just using what we know about volume of revolution to write an expression for the volume. So the volume of revolution, we can either use the formula or we can use what we've discussed previously about volume of revolution, and knowing that this sort of forms a disk rotated with its center at the x-axis. And so the volume is going to be pi times the integral from 0 to a, because that's the extent of this region. And then we're going to take r, the radius of this disk, which we can see is the height of this little strip. So this strip, which is rotated around the x-axis, its radius is the height of the function. And so to find the volume of that function, of that disk, it's going to be our y value squared times its thickness, which is dx. And we know that y is equal to the square root of x because that's given. So we know then that the volume is pi times the integral from 0 to a of the square root of x squared dx. And now we can simplify this integral a little bit. This becomes pi times the integral from 0 to a of square root of x squared, which is just x dx. And now we can use our integral knowledge to figure out what this integral is actually equal to. So our lowercase f of x here is x, which means our antiderivative function, f of x, is going to be 1/2 x squared. And what we now need to do is substitute this antiderivative function and evaluate it at the two limits of integration of this integral. So I'm going to bring down that pi, and I'm going to multiply it by capital F of a minus capital F of 0. So that's pi times 1/2 a squared minus pi times f of 0, but substituting x equals 0 into that expression just gives us 0. So we're left, in the end, just with the fact that this volume is equal to 1/2 pi a squared. Now the part of the question that we haven't used is that the volume of the solid is 32 pi. We have just found an expression for the volume of the solid, saying that it is 1/2 pi a squared. So we set that equal to 32 pi. A little bit of algebra, divide out the pi's. We end up with the fact that a squared is equal to 64, which gives us a single value of a equal to 8. So that's how we solve one of these volume of revolution questions, where it's not just find the volume, but go one step further to perhaps go backwards and think about this concept a little bit differently.